In this video, we're going to talk a little bit about making your shell code a little bit harder to detect. Now, a very common way that we do this is to encode it with some sort of encoder. There are a few different options out there, and certainly you could make your own encoder, but there's really not a reason to do that because Metasploit comes with a nice set of encoders. So if I look at the encoder, it's called MSF encode, I do a -L and then -A x86, it will give me a list of Intel compatible encoders. And because it's written in Ruby, it takes a long time just to come up with this very basic bit of information. All right, so here we have a few encoders. They each have a ranking and a description. So we can say, I only want alphanumeric characters, or I want to use something a little fancier like Bloxer, a metamorphic block-based XOR encoder. Or maybe I want to use a single byte countdown XOR encoder. I can say, I only want non-uppercase, non-alphanumeric. And we have Shikata Ganai right here. This guy is the only one ranked as excellent, although it has its problems as well. So the idea is you want your shellcode not to be detected by intrusion detection systems. So using an encoder can help. Before we can really use the encoder, we have to first take our shellcode and put it into a format that is easily used by MSF encode. Remember, previously we had a little shell script that was all one line of code right here, minus this second echo command that I've inserted there. So this is new. And essentially what I've done is unwound this. So it's not all in one line anymore. Quickly, let's walk through this modified shell script. We have our shebang bin bash, a couple of comments, and then we set our output file name. And we say our output file name, which I've called bin file, is equal to our input file name with .bin at the end. Now here, this construct, $, and then a command in parentheses will execute this command and then return the result. And the command is called base name. Base name will give you just the file name, not the entire path. So this will output into the current directory from which it is run. I then do a simple test. I say, if this file exists, remove it, please. Then I echo my C code. Character code array equals, and then a starting quote. And here's our old script that we saw from before. I echo out all of these codes for each byte. Here's the done, where my loop ends. And here's what I've added. I've added a new line that says echo. The -N says do not echo out a new line. Otherwise, every single byte would be on its own line, which is bad. The -E says please expand escaped characters. So when I say \x and a number, it's going to say, oh, you meant a byte with that value. I then send all of that to bin file. So the greater than appends to the file. And that is why I removed the file earlier. If I didn't do that, this file would end up corrupted. Now, there are other ways that I could have implemented this, but this seemed by far to be the simplest. Once that's done, I echo out a closing quote, and I've created my file. So real quickly, let's go ahead and run this on our Windows shell script that we used in previous videos. So I'm going to run my new shell script, Win32 shell, and there's my code. Now, if I look and I do an ls, I will see a new file, win32shell.bin. If I look at this file using something like xxd, I will see that it should start with EB16, etc. to match my C code. And sure enough, it starts with EB16, which matches this right here. And it should end with 7865, and it does. Also, we see the ASCII interpretation, And remember that this would run using winexec command.exe/c calc.exe. So that's fairly simple. We're going to take a brief break, and when we come back, we will talk about how we can encode this script with another shell script.